Sorry, so it says Newton is the force that producing an acceleration. This here is there's an error there. I'm just spotting it of 1 meters per second square. When it acts on a mass of 1 kg. As I spoke about SI unit, right there, I saw that this was not square, it was to the -1, which is saying it is velocity, right? So I made my correction. All right, let's proceed. So you remember these basic formulas, eh? These basic explanation of Newton's law. So you remember Newton's third law, all these three laws, and Newton has a fourth law which talks about the universal law, right? That you may come across it at some stage. I think in statics you do come across that one. All right, universal law. Anybody know that one? Newton, one of Newton's universal law. You guys know about that one? Anybody know it? So you remember these three. That is, say if a body continue with uniform acceleration in a straight line, unless acted on by some external force, it will continue to move in that direction. Now, right? That is one. That is the first law. What about the second law? Everybody know it. It says the acceleration of object is directly proportional to the net force. And in our case, what was the net force? The net force is similar to what we call the external force, and is inversely proportional to the object's mass, right? The direction of the acceleration is in the direction of the net force acting on the body. Or you could simply state it: the rate and change of momentum of a body is directly proportional to the external force acting on the body and takes place in the direction of a force. Because remember now, acceleration is a vector quantity, velocity is a vector quantity, so it must take place in its direction of the force, right in this instant, but it must have direction. That's the point that I want to make. So the fact that acceleration is proportional, it has a direction. All right. So acceleration of a quantity, velocity is a vector quantity, force is a vector quantity as it applied in a particular direction. All right. And so we talk about acceleration and velocity. And displacement is a vector quantity, not distance, displacement. Right? Okay. So remember now that term displacement. The third one, everybody know about equal and opposite reaction, right, of a body. So we won't even go into that one. It won't be really so essential here. So we have the 2D frame, as I said before, and it describes for the 3-dimensional, U goes down to K. If it's 2-dimensional, it's just I and the J we refer to, right? So this is displacement, not distance. That is velocity, acceleration. All right. And this is 2D frame. So see a 2D frame here, and the velocity can be expressed in the x-axis and the y-axis. See them there? And this is similar to what we have here, talking about the sum of the net force, right? Which equals to MA, right? And it shows you that the force can have quantity in the I, the J, and the K direction. That's the essence of that. You will not have time to read that, right? So unit vector is a vector with length 1. Length is always 1, and it has R1. And it has no unit. But of course, it has what? Direction, because it's a vector quantity, it's a unit vector. So unit vector is the word you always talk about 1. So it's used as specify a direction. Eh? Always specify a direction. So what is the unit vector I represent? Can somebody tell me that? What does the unit vector I represent? Can somebody tell me what the unit vector I represent?
Sir, what you mean?
Unit vector I, what it represent? What unit vector I represent?
Direction.
All right, unit vector I in the polar coordinates I, J, and K. What's the unit vector?
Sir, and Y.
Pardon me?
Along the y-axis, so?
I is referred to is on the x-axis. No, sir. So remember now. Remember.
X.
So you have, right. And if let's say that this is x, this is y, and this is z.
Oh yeah.
So if it's unit vector and I say
X.
I, it is this axis, right? And if I say
X,
j is this,
yeah.
1 unit mean that it move 1 unit along here. And if it's j, 1 unit along here. And if it's k, 1 unit along here with k. All right, that's what I'm simply saying. All right. So when it has a unit vector of 1, it means that it gives you direction. And because of those quantity, you are able to identify certain specifics. So it is used to specify a direction. Unit vector U points in the direction of big U. So in other words, it is donated, it is the donation of it, donated as U. Sometimes you will see it with a little hat over it, or you will see a modulus sign in front of it. The modulus of 1 is 1, don't? So the modulus means the real number of it, all right? So it's depicted in several ways, all right? Can I clear this? I think so. Something needs to be clear. Get off this. So you see the unit vector show you that it's some in direction, all right? So that's a little bit of clarity. So it's a unit vector in one direction. So if it's I, 1 unit in the I. If it's J, 1 unit. That's what it means. So use an example in the Cartesian vector form. So in the Cartesian vector form, we see the I, J, and K. But you can represent it in the polar form. The polar form is where you use the angle. So you could have a cos theta I plus a cos theta J plus a cos theta K. The angle is the angle at which the angle, the x-axis referred back to the origin at some point. All right. And likewise, so the y axis is where you have the theta j, the cos theta j, and likewise for the z, the cos. So in shortly we'll do something to refresh you of that somewhere along the line, right? But the polar one, probably I don't labor too much on the polar in this session, but it will come up somehow. All right. So this is in the Cartesian form where you have the displacement in the x, displacement in the y, displacement in the z. So point in the direction of it. And remember, it's one, once it's unit vector, 1 unit in the direction. All right. And we also will look at a briefly position vector. So the component of the position vector is really in space. The component of a vector can be written in Vx, Vi, Vy, J, or Vz. Right? So it can be written in any one of these forms. So therefore, you have Vxi, Vyj, right? So Vxi plus Vyj, and so forth. Now, so what this really showing you is that you have components in any one of the axes. You can have it in the x, y, and z. And it is donated by, if it's y is j, if it's x is I, and if it's z is k, right? And also, if you have two components, if you have the vector vu, look at this one here. The vector v, right? Vector v. If you have the vector v and it is equals to xi plus vyj. Now, if you're adding these two, let's say that you understand that v, you have the vector v has these components, right? So it has v1, v2. All right, and let's say you know v1 and v2. But v1 and v2 have its own components. You notice them? But v1 it have a x and it have a y. But they're in I and j. And likewise v2 have a I and a. If you need to get v1 plus v2 for v, all you need to do is group them. Look for where all the i's are, look for where all the j, and you add them. And you would have done so. This is addition of vectors, right? So if you're summing two vectors, you look for where the the similar Cartesians are in terms of I and I, J to J, and if it's K, it's K to K, right? And you had, which is addition of vectors. Right, so this depicts what I was saying before, right? It's a bit of repeat of that. So this is just a 2D frame, all right? And as I said before, I think one of these slides, something come before, let me see what comes after. Not this. Something is a little bit out of place. I realize. All right. So, all right. The first thing we look at here, it says the average and instantaneous velocity. So look carefully. What is average velocity? Average velocity deal with displacement over some interval time interval. So some change in time and some change in the displacement, right? Give you average velocity, all right? And average velocity can also be depicted in the Cartesian format, wherein the change in time is divided by the individual quantity. So you can divide individual change in the displacement in the x, change in the displacement of the y, and this will bring it into a unit vector format, or you could say the Cartesian format. All right. So it can be displayed. So remember, this is displacement, that is time. All right. That's about average velocity. What about instantaneous velocity? Instantaneous velocity is where calculus comes in, because it happens at a one point in time. Right? It happens just at one point in time, and you must be able to calculate it. That's where calculus comes in. Calculus is very precise. It gives you a point in time, or it maps an area. So some expression help you to map an area. When you differentiate, well, it's more integration. Integration really helps you to map an area. All right. Differentiation help you to identify a particular point, a specific point. All right. So let's get that clarity there. All right. So just like how we had velocity, you can have average acceleration, which is what? Change in velocity upon some time interval. And likewise, it can be depicted just like the velocity there, where you have the Cartesian format. The Cartesian format include the unit vector components. And you have instantaneous. Instantaneous, again, is where you differentiate an expression. So if you differentiate displacement, you're going to get velocity. If you differentiate velocity, in this case, you differentiate velocity, you're getting acceleration. All right, and you can get these components likewise. All right, and that depicts instantaneous acceleration. All right, so I think this is a little repeat from before, where it actually show you how we move in first principle to get differentiation. So as the limit as zero go to as x goes to zero, it changes to zero, then it moves from delta x to dx, right? So and the same thing for time. Both when x and dx go to zero, it gives you dx upon dt. All right, for you differentiate the displacement, right? So the delta x here moves to dx as it goes, the limit goes to zero, right? From t, and you have done that from calculus. So I will not dwell on that too much. All right, average. So the average velocity, as I said, this was done before. It actually showing you clearly how is average done. So the average is a displacement. It is between the initial and the final displacement. The difference between initial and final displacement can help you to get your velocity, and likewise for the time. So average velocity includes what? Final, the difference between final and initial displacement, all right? And likewise the time interval between both. Instantaneous velocity, it is a point in time. So as the delta x go to zero, or delta the x go to zero, then become dx upon dt. All right, so it's the slope. All right, so it's a gradient. It talks about the gradient. All right, the slope of tangent line equal to the instantaneous velocity. So it's the gradient at that point. It helps you to depict. All right. So we are look at instantaneous velocity. Let's suppose you have this expression here, which says the displacement is equal to 6t squared minus t2. Taking this as displacement, this as time. And when you differentiate an expression like this, you're going to get v is equal to dx upon dt. And as such, this becomes 12t minus 3t squared. All right. So as you reduce the index and multiply by the current index. All right. Okay. Likewise, we have done this one. A particle moves along the x-axis according to the expression x is equal to minus 4t plus 2t squared. It says first determine the displacement. So if you get the displacement, right, you so first you said determine the displacement of the particle in the time interval, right? So it moves from 0 to this. So first when it is 0, everything, the displacement is 0, don't? And when the time is t, the displacement is minus 2. So you put t equals 1 here. First one you did was put t equal to, anywhere you say t, you put 0. And you get 0 for the displacement. For the second one, anywhere you say t, you put 1. So this one will give you minus 4. And this one will give you what? Plus 2. So the difference between minus 4 and plus 2 is minus 2. All right. So here you have it. So and then now to get the displacement, you're gonna get the final displacement from the initial, and the here it goes. So it's minus 2 meters. That was the displacement. All right. Notice I'm not saying distant. There's a big difference. All right. Because distant is not a vector quantity. Displacement is. All right. So it's come on, where am I now? Let's jump away. All right. What about the average velocity? The average velocity, what we say, is a change in time, the change in displacement over the change in time. So between the time here is 1, between 0 is 1, and the displacement up here is minus 2. So you subtract, you divide the time by the displacement, and you get minus 2 meters per second squared. What about if it talks about instantaneous velocity? It's talking about what is the gradient of the slope at that particular point. So the gradient of this is taking the differential of this. So the differential of this is going to be minus 4 plus 4t. So it's minus 4. So you differentiate this, you get minus 4. So you reduce this by 1. And this one, you reduce it by 1 and multiply by the current index. So it's 4 times t. So you get that expression. So this is now your velocity is equal to minus 4. So this is your velocity expression. Now, and it happens at the particle at 2.5. So at 2.5, you must drop it in here to get your velocity. So you put t equals to 2.5. You are getting here 2.5. The time is 2.5 plus this. Right. So 2.5 times this gives you 10. Difference between 10 and minus 4 is 6. 6 meters per second is the answer. All right. Any questions so far? Nothing? All right. The instantaneous
Sorry,
acceleration.
can you go over that one more time, please?
All right. So allow me to run along, and then I leave you behind and you say nothing. All right. What which section you want me to go over? Everything?
Yes,
Right
sir.
here?
Yes,
Entire
sir.
question?
Yes, sir.
Yes? Entire question?
Yes, sir.
All right. So what we're saying here, the particle moves along the x-axis. And according to the expression, so it moves along the x-axis, but it gives us an expression. So it gives us an expression. From once you get an expression, then you're in business. The first question asked was the displacement of the particle in the time interval. Now, what is the time interval? It moves between 0 and 1 second. All right. So if it moves between 0 and 1 second, I can find that displacement. So when it is 0, the displacement is 0. That is straightforward. When it is 1, what is the displacement? I drop 1 in that expression there. Anywhere t is, I drop 1 there. And I get in I get minus 2. Everybody see how they will get the minus 2? Appreciate it? Yes, no, maybe so. So where I say x, come on. All right, what's going on the right side? All right, let's see if I can get the writer to work. But it's not in its selected mode. All right. So x is equals to minus 4. Anywhere one, t is you put 1 here, plus 2, 1 square. So this gives you minus 4 plus 2. Right? And that gives you a minus 2. And of course, it is in meter. So that gives you that section there, the top section. Now, to get the displacement, because remember, people ask you for displacement, you know. They never ask you for just minus 2. Right? So you have to know it's a difference. So the change displacement is going to be, if you want to call it, x2 minus x1. Or let us use big X. X1, x2 minus x1. So it means that x2 would have been what? Minus 2. And then it's going to be a minus 0. So that is giving you what? Minus 2. That's a difference. See there? All right. And then this one now, average. So now you have the displacement. Remember what velocity, what average velocity was? Average velocity was, it was depicted as xf minus x initial upon tf minus t initial. And so that's what you do. So it's a change in the time, and this is a change in the displacement. But we have a change in displacement already, it's minus 2. So it's minus 2 divided by the change in time, which is 1. So the velocity is minus 2 meters per second. This one here now, you need to get the instantaneous velocity. So at some curve, when the x equals 0, you need to find where your velocity is. But you have the expression, right? When we differentiate this guy, so we have x is equals to 4 minus 4t plus 2t squared, right? So when you differentiate, you get minus 4 plus 4t, right? And so, right? So everybody see it? No, everybody okay with that? So now this is 4 plus, and what, and it happened with 2.5 times the 4 is here. So 4 times 2.5 is 10. Add to minus 4. So you get 6. So right, so you get minus 4 plus 10 equals to 6 meters per second. Everybody good right there?
Yes, sir.
All right, so let's start. All right, so the instantaneous acceleration is pretty much the same. To get instantaneous acceleration, it's 2 differentials. So you have to differentiate velocity. After you differentiate velocity, you could actually write it dx d square x upon dt square. So to get instantaneous acceleration is 2 times you differentiate the same expression. So let's go back down here. If I was to get the acceleration, I would have to differentiate this. Can somebody tell me what was give me the acceleration expression from this? Knowing this, give me the acceleration at t equals 2.5. Can somebody give me the acceleration at that point? I'm waiting. So I'm gonna wait until somebody talks to me.
I try. Me dey delete the message. Me dey delete the message them. I can't find but the email address. Tell me the email address.
Hello? Hello? Somebody, mic is
Me dey
muted.
delete the message them.
Hello? Hold
This
on.
one
What's
like
going
yeah
on?
work so.
What's going on here? Somebody,
This one like yeah work.
oh my goodness.
Me love for this right there now.
Who was that? Someone was there talking. Is that Kenrick? Kenrick was disturbing us. I think it was Kenrick. I'm not absolutely sure. Who want to explain that to me now? I need the acceleration when it has the instantaneous velocity. What is the acceleration, please? I'm waiting. When t equals 2.5 and the velocity. So what's the velocity expression now? Everybody know it? Velocity expression is minus 4 plus 4t. So I want the acceleration from there. Before we move further, somebody tell me the acceleration, right? So I will wait until I get my answer. So you think about it and you brainstorm and come up with it. Somebody tell me. So I wait until you resolve in coming up with the answer.
Alright, so that'll be all of that divided by C.
Go again.
So would it be all of that divided by C? All of the expression.
Let me see if I
for
hear you good. Come again. I'm a little challenge hearing you. Let me see if I hear you again.
I'm saying the expression for velocity, all of that divided by C with time.
You said the velocity is gonna divide it by the time?
Yes.
No, I want it to. All right. Let me put it this way. Give me the expression. And then you find the acceleration from it. Give me the expression. So if you divide the velocity by 2.5, you're gonna get a figure, don't? But is that correct? I want the instant. Let me tell you what I want. I want the instantaneous acceleration at the same time. So we have the instantaneous velocity. What about the instantaneous acceleration at that time? So at that point in time, I want the instantaneous one. I didn't ask you for the average one, you know. I want the instantaneous one. I think I'll give you enough information for you to tell. I want the instantaneous acceleration. Now that I have the instantaneous velocity, right? I want the instantaneous acceleration. How do we find acceleration? How do we find acceleration, guys? What did I tell you to do with to find acceleration in terms of this system of expression? So remember, everything has to do with an expression. You know, you have to start with an expression. So in this case, we're starting with displacement expression. And then from that, we get what? Our velocity expression. So how do we move on to the
final velocity minus initial velocity over. So sorry, that'll be final velocity minus initial velocity over final time minus initial time.
No, you're thinking too high, man. Remember what you have here saying now. It says instantaneous velocity. You remember how we find the instantaneous velocity? See it right here now. What did we do to find the instantaneous velocity? What did we do to find the instantaneous velocity? Kenrick, have you been back with us? Kenrick, are you back with us? Kenrick, are you back with us? Kenrick, are you back with us? Who else is in the class? Who was speaking a while ago? Was it Baker? What about Bacchus? Bacchus, you understand anything that is going on? And listen to me, guys, the class is small. I want you just to just interact and let us get on with the material so that everybody can be on the same page. All right, I don't want to leave anybody behind. Montague, you're the one talking before?
Yeah, we are common to me.
You're the one answering before?
Sir, the name is Monique, sir. Yes,
Sorry,
sir.
sorry, I'm sorry. Yeah, Monique. Doing. Yeah. Do you understand anything that's going on? So we have found the displacement, find the average velocity. And can anybody tell how we find average? All right, instantaneous. Let us go back. For all intent and purpose, I want you to look. See if you see anything. You look for me. Look. You see this? It says instantaneous acceleration. You see what is instantaneous acceleration? What do we do to get instantaneous acceleration? What have we done right there? You realize that this calculus you use right there? When you differentiate the velocity expression, this one here, this one right here. When you use this, you automatically get in your calculus. See here, dv upon dt, the differential of the velocity. So this could be written how? This could be written as dv upon dt. Yeah, so what that's saying, you're differentiating your velocity in respect to the time, and you will get your what? Acceleration. So I want you to do that now and give me the answer. Say no more. Give me your answer now, please. For all those persons who are sleeping on me, come. We are not, I don't want any spectator here in the class. So someone come up with the answer for me, please. I'm waiting. You are going to now differentiate. So let me write it for you. Are you going to do it? dv upon dt. You're going to differentiate your velocity expression in respect to your that. And I want you to give me the answer right here. Using your differentiation. Question. Everybody else here have been introduced to calculus? Have you done calculus already? With your maths teacher? Hello? Hello? Can somebody talk to me, please? Bacchus?
Sir, we're currently doing calculus. We did pre-calculus last semester.
Oh, good. So therefore, there is absolutely no reason why a person should not be able to communicate. All right, so what is the answer there for me? The fact that you guys are done pre-calculus and are now doing calculus, what is the answer right there? So the instantaneous one, acceleration at t equals 2.5. When you use your calculus, you will know what the answer is. Probably don't need to do anything else after you have done that.
Hello.
Yes, what is it?
Amy.
What?
No.
Someone saying something? Kenrick, I came fall asleep, man. Kenrick? Mr. Harrison? Mr. Harrison? Abigail? Abigail? Listen to me, I don't want anybody with any coward attitude inside here. Just open up the mic and talk. Is either right or wrong, I will move on. Right? But if you're going to stay in your corner and hide in your corner, that's not gonna work. All right? Come on, man. Somebody talk to me now. Someone talk to me, please. I'm waiting. And I don't want the class, guys, I don't want anybody pretending inside. If you don't understand, you don't understand. Am I to get it that the class is not comfortable with calculus?
I'm not fully comfortable, sir.
Right. So that is why you must be frank with me. And don't have me there hiding behind it. Just be frank with me. If you don't understand the calculus, tell me say you don't understand it, you're not comfortable with it. So you know you attempt it, but you're not comfortable. Would you all right? So question, if I give an expression like this, you all cannot differentiate it. That's what you're saying. You cannot differentiate this. So all right, I'm gonna stop sharing. I'm gonna discard everything that I have here. And I'm going to ask you again, we are going to take the same expression here. And we're going to do a number then. All right. Let me just copy. And I open something else. And I will just all right. So let us just stop sharing for a moment there, and then I start. So that's all you have to say. You say to me, all right, sir. I am not too comfortable with this thing, you know. Right? And if that's the case, then when I know what to do from there, I know how to treat the thing. But don't pretend you guys don't need to hide behind just be frank. Sir, I'm not comfortable with calculus, and that's why I start asking you that. Right? So what I want you to do is just be truthful to me and tell me, say, okay, I'm not. So I want to know where you are, you know, when I'm teaching you. So so all right. So rather than I going across it and saying that everybody understand everything, I know that I must tread carefully. All right. So x is equals to minus 4 t. Now I could have said that I finish this topic, you know, and move on, but this topic has to do with calculus. So I run it. So now this is in what? This is displacement, right? This is displacement. And we said here, when you differentiate displacement, you get velocity. When you differentiate let me write it this way. When you differentiate velocity in respect to t, when you differentiate this, you will get velocity. When you differentiate velocity in respect to t, you will get acceleration. So this is simple what we're doing. So the first one we're going to do is differentiate this figure here. So it goes, all right. So it goes like this. Minus 4. Now t is up here. T is to the 1, correct? And then you're going to minus 1 from it, but you also multiply it by 1. Not true. So that part is all right. Plus, let me expand because it's all right. So then the next part is that is the first part. All right, tell you what. Let me clean that up and read much better. Everybody see what I'm writing?
Yes, sir.
All right, let's write it again. Hey man, you just talk to me, man. Let me know. Don't pretend, right? Don't pretend that you understand the thing or you don't understand. So all right, so we have the 4t. This is what we have to integrate. Minus 4. Rewriting it again. This is just so it's minus 4t plus 2t squared. What we do with the first one, we are going to reduce it. The index is to the 1, right? So we're gonna multiply by the index, whatever your index is, minus 4. So it's times 1 times the 4. You keep the minus out there, so in other words, so keep the minus out there, so. All right, and you put your 4 here. Now the t is going to move from t to the 1 minus 1. Because you have to reduce it. All right, plus, let's go to the next one, the t, 2t squared. So it's whatever the index is, you multiply it by the existing constant there. And then, of course, you reduce the t by 1. This is first principle. So therefore, this gives me minus now. Minus 1 times 4 is 4, and this is minus. And anything t minus 1, this will give you what? 0. So it's really t to the 0.
Which are 1.
Plus 4, and this is t. 1 from 2 give you what? 1. That's all. So in other words, you can write this as minus 4 Now t to the anything in indices t to the 0 is 1. So therefore that is so that is 1 there plus 4t. So therefore that gives you minus 4 plus 4t. It's as simple as that. And what we did was they said to find the instantaneous velocity. So once you see the word instantaneous at a point in time, you know so it's calculus. So all we did was to substitute the minus, and the time was at time 2.5. Right? So the time was 2.5 seconds. So all we do is go minus 4 plus 4, 2.5. And that gave us what? 6. All right, direct number, because that was 10 minus. All right. The next part was that I said to you, give me the acceleration. For the acceleration of a figure of this expression, now your velocity is really now, so the velocity, so we said the velocity expression is really equals to minus 4 plus 4t. So, right. So now when you have velocity, you can get acceleration, but you have to do what? So differentiating of the velocity in respect to time, v, so that is what is there. In order to do this, you differentiate here. When you differentiate a constant, it is 0, right? When you differentiate a 4t, which is an algebraic term, you must reduce the t here by 1. So if that is t, it's going to be minus 1 from it, right? So, and it's 1 times the 4, which you know that you can just write 4.
Yep.
So 1 from that is t0. And therefore the answer is 4 meters per second square. So that is the answer when t equals 2.5, the instantaneous acceleration. So what we get here, so now this gives us acceleration. Not writing good with this right here. All right, so the acceleration is 0 plus 4. So that you get that clearly. All right.
That good now.
Pardon me?
Yeah, mom, I get it now.
All right, good. So all the other guys will tell me, are you there in the behaving as if you don't understand and you don't understand? All right. And we could have let me just believe that, oh, these guys are wonderful with this integration, and I just leave it and run on because I'm just about to do that. All right, so that now, so right, so that's it. That's all you would have got. Get your instantaneous acceleration. So your acceleration at that point, you differentiate this figure, and you look at it, you can see that it is really 4 meters per second. Of when you do d upon dt, close to the of minus 4 plus 4, right, which is the velocity. You differentiate that to inspect it. All right, so let's jump over. All right, so we see what is your instantaneous. So it says here instantaneous acceleration. If we wish to know the instantaneous acceleration, we once again let the t goes to 0, and you get dv upon dt. So here, when you differentiate displacement velocity, you get dv upon dt. But when you do so 2 times, when you differentiate the velocity again, is actually you get dx squared x dt. So that is a second derivative of displacement give you acceleration. If you notice, this is displacement here. So what I'm simply saying here is when you get a displacement expression and you differentiate it twice, you get that. All right, so in this case, you have the velocity. All right, so now you have a velocity expression. When you differentiate velocity, we get acceleration. So let's show you how we get this one here. So what we actually have here, this is really saying when I differentiate in respect to t, my velocity. I get acceleration. That is what it really says. And how did we get all of that? So when you differentiate the first one, let's do it. The first one, you have, let me write it somewhere again so that we can.
It's on a 12.
So it's 12t minus 3t squared. All right, so the first one, you're going to reduce the t index by 1. All right, and remember the index is 1. So first, right, so it is 1 times 12. All right, I still put in the 1. If it's another figure, you know, you multiply it. And then you have t to the 1 minus 1. All right, so that's the first one. And the next part is minus 3 times 2, because you multiply it by 2. Or maybe that confuses some people. Let me write it. Hold on. That's not really how it should be written. Let me just write it. Just experience. So it is really minus 2 times 2. You can consider that as the sign there. Times 3 t squared minus 1. So this gives me 1 times 12 is 12, and t 1 from 1 is 0, plus minus 6 t, because 1 from that gives me just t1. All right. So in other words, this now, anything to the 0 power is 1, so that is 12, and this becomes minus 6 t. All right. So it's as simple as that. Right. And from that you get your acceleration expression. So if they actually give you a time, and they say acceleration expression, let's say 1 second. If it was 1 second, then you know the acceleration is actually 6. If it was 1, you put anywhere t is, you put 1, and you have worked out. But they did not. They just asked for the expression because this is just starting your house. All right. So that's how you have dealt with that. And so the average is different. The average only have to talk about initial and final and whatever. Right? And acceleration is a vector quantity. The unit is meters per second. You know all of that already. Average acceleration can be positive, negative, or 0. All right. Last time we looked at this here where we had the expression here, at squared plus b, given that a is 2.10, 2.1, pardon me, and b is 2.8. They say to find a displacement. All right, so without even looking on the answer, let's just jump on it. Answer is around here. First thing you do, you identify a and b so you can formulate your expression. So you know x is really equals to 2.1 t squared plus what is b? 2.8. So that's a constant. It says you are to find the displacement of the engine during this time here. All right, so the duration of the time is between 3 and 5. So you know it's 2 seconds. The change in time. So you know from this, the change in t is really 5. Come on, writer. Minus 3 equals 2 seconds. All right. First thing you need to do, you need to consider it individually. So when T1 would have been the start, the initial time, and T2 would have been the final time. So at T1, right, when T1 equals to 3, it implies that 2.1 bracket 3 square plus 2.8. And that, if you can somebody work that out in the meantime, so we'll have know what the displacement is at that time. So it implies that the displacement is whatever that works out to be. And then what is the displacement when T2 is equal to 5 seconds? All right, so the x now, so that is x1, and this is x2. It's going to be equals 2.1, open bracket, 5 square plus 2.8. What is the both time? It answer is over the other page, but just for clarity before we reach here. Somebody can work that out. All right. They say they want the average velocity. So the average velocity is going to be what now? It's going to be x2 minus x1 upon t2 minus t1. So it's a change in displacement upon the change in time. So whatever you get with the answer for each one of them, divided by the time. And you know the time already, it is 5 minus 3. All upon x. So this is x2, and this is x1, pardon me, and this is x2. So it's a difference between them. Did anybody work it out? So 1 is 9 times 2.1 plus 2.8. Right?
Yeah, that's a 9.1.
Pardon me?
9.1.
So for the first one, for which one of
Yeah.
them? The first one,
First one.
9.1. And then the other one is what?
13.3.
13.3. So you subtract them and divide by 2. And you would have gotten the average, you get when you subtract these two, you get the displacement. What is the displacement? So the displacement is x2 minus x1. Whatever value. So it is 13.3 minus 9.1. That is your displacement. So your displacement divided by your change in your distance over the time, change in time, give you your answer. What is that answer, please? So what is the average velocity? Average velocity, please. What's the difference between that? 9.3 and that from that value. How much you get there? 9 from 13. How much is that? 4. So it's 4.2. So it's 4.2 over 2. That's what you're telling me, you know. So if that is the case, it is what? 2.1 meters per second. All right. Determine the magnitude of the instantaneous velocity when t equals to 5. All right. I need somebody to try that without, I want somebody to try that for me now. So the expression that you're going to work with is the one, can write it big and bold at the top. So it is going to be, x, come on, x equals to 2.1 t square plus 2.8. That is the expression. I want you to find your velocity, and then from the velocity you're gonna, so first thing you're going to find for me, velocity. The next thing you're going to find is the acceleration. So it's 2 stage. And you're gonna do it when the time is what? 5 seconds. Right. So I want the instantaneous velocity and I want the instantaneous acceleration. So I'm giving a part D to it. So I'm gonna drink some water while you guys clear your head, while you start working that, so we can have a discussion. Right? So we have a little time to go. Oh, by the way, remember meantime, right? So I'll give you some time, like a 5 minutes, I'll give myself 5. You are going to put your name in the chat as registration, please. Please register, right? And if somebody who came to the meeting has fallen out of the meeting, you can drop their name in the chat, please. All right. So I'll close my mic now because I don't want this dog even to be in the record. All right. Anybody finish yet? Anybody finish? So I see Monique. Anybody? Monique have something here. All right. Well, we'll see how that go, Monique. Anis. Anissa,
Yes, sir.
what about you? You finish work the problem yet? You do which part you do? You do the velocity yet or you do the acceleration? The instantaneous velocity. You try that part yet?
I'm working on it, sir. I'm working on it.
All right. So you want a little more time so we can discuss it. So we okay, all right. What I'm going to do, if I'm gonna stop share, it might ask me to clear everything. All right, what I'll do then, so I'm going to do. Don't make you lose everything in that. Come on. That one is not productive. Let's go again. All right. So I'm going to stop sharing. And share. Stop. And I'm going to stop momentarily. And I'm going to go to OneNote. All right. So we're gonna go up to OneNote. We're gonna do a little piece. All right. So this is what you have there. In OneNote. All right. We're gonna make it a little bit smaller. It won't lose anything. All right. Good. Give me a little bit more writing space. All right. Fantastic. Now, so at least I can have my expression here on the other side. So it is x is equals to 2.t squared plus the constant 2.8. Now we could, or if you want to know, you could leave the constant out and just use the expression here, the at squared plus b. So you can do it either way and then you insert them after. Just know that they are constant. So you could choose to have the displacement looking like this, either this way or this way. Your choice. It might be easier in the second than the first. And then now you go d upon dt of x, which you know is velocity. And you differentiate now. So you differentiate this term, or even another way to write it. Another way to write it. You could actually put at squared, right? Everything is equal to 3. So therefore, v is equals to when you differentiate this. And then now you can do it the second time round. Right? Which is gonna give you your acceleration. All right. As I said before, you can write it in many ways. Anybody have the velocity expression ready? I think I see one person have something. Let me see who was it. Was it are you guys seeing what I'm sharing, by the way? Everybody's good with what I'm sharing, right?
Yes, sir.
All right. The chat. I saw someone did a workout. Monique. So Monique, you are confident in your answer? Yes or no?
No.
You're not confident. All right. Kenrick, are you back with us? Or are you still sleeping? Kenrick? Remember, you guys, need to do your registration. So make sure you put your name in the chat. All right. Sometimes the first thing you get in the class, just drop your name down as registration. All right. So far, I'm not seeing much person registering at all. I only have 2 persons' name in the chat so far. So Abigail, all right. Bacchus came momentarily and left. So there's one person who I haven't seen tonight. Who is that person? Who is missing from the group? Who hasn't shown at all? Bacchus, are you there with us? Bacchus look like he's sleeping from him come. All right. So the first one, let's differentiate this one here now. All right. Let me use a different color. So for this one now, you go 2 times A and the T2 minus 1. Now the B plus the B is a constant, so that's a 0. So this answer is 2A T. All right, so that is the answer for the first part. Now when you put in the constant, you're gonna get 2 times 2.1, where you have the A, and you get T. So you get 4.2 T. So that looks like you're right, Miss Baker. All right. And then for the acceleration, you differentiate again, which really is saying is 4.2 T to the 1 minus 1 equals to 4.2. All of that is equal to 1 meters per second. All right. Now, did they ask you for a time at the instantaneous? Say at 5 seconds. So at 5 seconds, you would put in 4.2 times 5. All right. How much you get there? 20.1 or something like that.
Sure, that is what for the magnitude?
Yeah.
Oh, 21.
It's not 20. I think it's 20.
21.
It's 21.
Yeah.
Something like that. Yeah, something like that. 21. And then you already have they didn't ask you for the acceleration. I just threw that into the mix. All right. So the answer is there. You can stop sharing and go back to it. But at least I just want you to have an appreciation, and you won't have an appreciation unless you try the problem. And that's the truth. Right? It tends to work. It's like it's something about the mind and the whole process. All right, so see them answers here. So this was the answer. Put in the value and you work it out. So you get 21.7 x1. So how did you give me that value there when you work out? That you're giving some wrong values there, man. And then when it is 5, it is 55. You didn't get anything like that. I don't recall getting any answers like these. How do you guys get the answer you derived here? Something went wrong there, man. So you check your
Yeah,
answer.
see your screen check because I'm not seeing what you're saying.
Oh, okay. Hold on. Come on. Sorry about that. I'm going back to the slides. So I'm saying the answer was right. Where were we? So this was a question. All right. This was a question. All right. And this was the solution. So now, remember the expression at squared plus b. A we know was 2.1. So when t equals to, so get the displacement where 3 is, you put it in. You get 21.7. And where for 5, when you put 5 in the expression, it give you 55.3. But we didn't get anything like that. Means that the workout that you did was incorrect. So the displacement is the difference. All right. Then now the average acceleration. All right. So the average acceleration is the
Sir,
total.
hold on, sir. Sir, oh you get that?
Where? Multiply
Sir, oh you
this.
get 21.7 because if 2.1 multiplied by 3, oh the 3 squared. Alright, I never right.
Yes, you never put this, the power. I know you did something wrong. Plus 2.8. And then there's the same thing. This is 25 times 2, you know, plus this. So it's 55.3. All right. If I was using presentation method, I would have said that what you work out. All right. And then the displacement is the difference between that. All right. So the average velocity is a displacement divided by time. 33.6 divided by 2, you get 16.8 meters per second. All right. All right. So the instantaneous velocity, right, is the differentiation of this. So C here is AT plus B, which is 2AT, and C here. All right. So the answer is 21. All right. All right. That was what you were to work out. They said the instantaneous and uniform acceleration, a particle is moving in a straight line so that its position is given by this the relationship, the same relationship. You have to calculate the average acceleration and the instantaneous acceleration. So the average acceleration now, same expression, right? And so the average acceleration and instantaneous, let's look at it in just of time. So the average, they say the particle is moving in the straight line and the relationship is given by 2, 1, 0, t squared plus 2.8. Calculate the average, right, and the average and the instantaneous. The first you need to find the velocity at t1 and t2 by differentiating. So when you differentiate this expression, you will get 4.2 t, right? I'll put the unit in it just to symbolize. So you can take out the unit if you want, right? So you find it now. When it is at this point, you're going to substitute t1 and t2 in this expression here. So you put in the 3, get 4.2. You put in the 5, and you get 12.6, and this is 21. All right. So all you do is 4.2 times 3 give you 12.6. 4.2 times 5. So that would have given you the velocity for each one of them. So the difference between the initial and final velocity upon the change in time is this. So see here, the average. So both of you do them by calculus or by average. And in this case, it works out to be the same. All right. Differentiate. The next one, if you differentiate 4t, remember as we had done it before. So the velocity is equal to 4t. Differentiate that, you get 4.2 part. 4.2t. 4.2t. Differentiate it, the t goes to 1, right? And you get 4.2 meters per second. Right? So to simplify the version, all right, so here's another one now. I know the answer is here, don't look at it. I want you to try it again for me. Let's say now the particle is given by x is equals to 2 t square, right? Or simplify 2t cube plus 2.5t. I wanted to first find the velocity expression. So you're going to move, first thing you have is displacement. And from displacement, you must get velocity. The displacement in this case is x2 is 2t, sorry. 2t cube plus 2.5. So what I want you to do for me, get the velocity, and the velocity is going to be dt x, right, upon dt. You differentiate what is x. So in other words, this is going to be d upon dt of 2.32 you got the point, plus 2.5. Differentiate that. Whatever you get, you need a d square x upon d square of the velocity, which give you velocity, of course. Right? Which not velocity, but acceleration. So when you differentiate the displacement twice, you get acceleration. Don't look at your answer if you have any notes, just do it and tell me. And somebody can tell me the expression without looking into your notes, please. Don't cheat now. Don't cheat yourself. Kenrick, you with us? Kenrick, are you with us?
Yes, sir.
Yeah, what happened to you, man? What happened to you? What happened to you? What's going on? Don't tell
Sir,
me.
I first maybe I'll call to me, I don't know what you mean by
How are you talking about the first? Whole night I've been calling to you. And
yeah?
I was saying to myself, Kenrick, you fall asleep.
No, man,
I have
sleep.
been saying that whole night. The other classmates
Sorry
can
about that, sir.
tell you that that's what I was doing.
There, man, sir, but show me a note taking kind of person, you know?
What's that?
Making some notes, yeah?
All right, so I want you to differentiate this displacement. Don't look in your notes, guys. All word, most things work out there, but I don't want you to cheat yourself. I want you to do it, get the gist of it, because let me tell you something. There's a little there's an unknown written law about writing stuff. You see, when you the psychometric, when you write things, you tend to remember it 100% more than if you just read it. I know it's for me. I don't know for a person. You have different learners. You have the kinesthetic learner. You have all different type of learner, the visual learner, all of that. But there are different people. You know, you have people who can just have they just look at something and a diagram and they remember it instantaneously, while others have to draw it several times. And some of us have to write the thing out. And so the mental structure of the brain works with the hand, right? So the more you practice, the more you become perfect. All right. So I want you to differentiate this something. All right. And don't look in the answer, please. You know, I'm going to start blocking some materials, because you guys are pre-reading the material before. Sometimes you don't understand it. Or just thinking that, oh, the material is there, I can read it anytime I understand. It's just a big difference, you know, from somebody who experienced with it, going through the material. So I still lead you on. Anybody two now? Are you body work it without looking at the answer now? Let me see. So Kenrick, you drop your thing in, all right. So we have money there. We have Anis. What about Bacchus? Bacchus, when you come in, you're not talking to us, you know. Man, you're quietly around here sleeping, you know. Bacchus? Is he left or is he still there? Is he still here? Amari? Bacchus? Could you unmute and talk to us, please?
Yes, sir.
Bacchus? Hello?
Yeah,
Yes, man, I'm hearing you, man. Welcome to the class, man. I can't believe that you're here.
Mom, they actually step off, up on the road quick.
Oh my goodness me. Whoa. At least you're honest. All right. All right. Who finished it now? Who on the start explain it? The first one. Who want to jump to the lectern and tell us how you do the first one? You can tell me and I write.
Oh, there is. We have differentiate velocity, displacement velocity.
Two persons talking at the same time. Who want to go? Two persons start talking same time. Who's going to do it? Bacchus?
No, I will the answer a while ago. I was asking a question.
Oh, what kind of question you were asking, sir?
No, I just read the question.
Oh. All right. Mute back and let she's because she's going to do it. Just mute, yeah, mute yourself, right? All right, Blackwood, come, let's go through it now. Let's just drop this off. Yeah.
Sir, would it be 2 times t square plus 2.5?
2 times what?
T square plus 2.5?
Plus 2.5. All right. Now, the last one is correct. First one is incorrect. So let us do it together.
Oh wait, sir, hold on. It's
Is it error now?
It's 6t square.
Okay, beautiful. All right. So let's do
2.5.
it together. Let's do it together. All right. Let's do it together. Hold on. Yeah, let's go back to our writing screen. Better we work around there. Sky. I like using this where is it now? One. Let's go with our one. Give us a chance to pick up the material very well. All right, good. Now, so one note here now. What it's simply saying here. So the problem is x is equals to 2t cubed plus 2.5t. So it's dx upon dt, which is really equal to velocity, equals to now 2 multiplied by the index, which is 3, t2 minus 1 plus t.5 times t, which is 1 minus 1. All right, if you multiply by 1, you get the same thing. So yeah, this gives you 6t, 1 from t3, t2, plus 1 times 2.5 is 2.5. and 1 prime that is t to the 0, which is actually 6t squared plus 2.5. All right. All right. So that is your velocity, and the acceleration, which is the acceleration, is really dv upon dt. Sorry, dt. Acceleration, which is the same thing as d square x upon d t square. All right, so those two expressions are equal. This one is really equals to 2 times 6 t to the square minus 1 plus the differential of 2.5 is that gives you 12. All right, and they say that you are to do it when t equals 1. All right, so the velocity up here, you could have easily find the velocity, because, well, the acceleration I really want to find, but you'd have to find velocity. So the acceleration is 12 times 2, which is 24 meters per second. All right, you could find the acceleration by putting 2 up here. If you put 2 up here, you'll get 2 into this, 2 is 4, 4, 6 is 24 plus what now? 2.5. So that's what, 26.5, something to that, okay? Meters per second square. All right, so that is how you do that section. All right, stop share again. Okay, all right. So now let's see what else we have here. So here's it workout, pretty much same thing. All right, workout here, and that is what the velocity is equal to. This is the acceleration. So pretty much work out there. All right. Okay. So we're saying the particle moves along the x-plane. In this case, its position as a function of time is given by x is equal to 6.8t plus 8.5t squared, where t is in second, x is in meter. What is the acceleration as a function of t? So it's known that velocity is equal to dx upon dt, and acceleration is dt, dv upon dt, or the second derivative of the displacement, which is d square x upon dt square. All right, and this is a simple one to solve. So let me just show you how to do it. All right, so let's go again. Stop sharing. All right. This is pretty much that problem. All right, so what you do, again, for reinforcement, let's use a black writer. Come on. So the displacement is equal to 6.8t plus 8.5t squared. So you get the differential of x in respect to time, differentiate time. So the first one is going to be 6.8 t to the 1 minus 1 plus 8.5 times 2. Okay, multiply whatever constant by the index, t to the 2 minus 1. So this gives you, this is t to the 0, which is 1, so it's 6.8 plus, what's that, 19 or 17? 17 to the 17 t, all right? So that's your dx upon dt, which is your velocity. So your velocity expression is that. Now that you have your velocity, you can get your acceleration. So they say, what is the acceleration? So, but you have to know that you have to get velocity first. So your dv upon dt of v says dt of 6.8 plus 17. All right. So what you simply do, but this is equals to acceleration. So your acceleration is equals to you differentiate the first one, you get the 6.8 is 0, right? So 0 plus 17t to the 1 minus 1, right? Times 1, of course. So you get here, it's 70 because t to the 0 is 1. So it's actually 70, right? Did I? Any question there? Any question? They didn't give you a time, so you can't get the problem down any further. All right. So, let me stop sharing that and go back into our notes now. This is back in our slide. Okay. Now, any question so far? Nothing that you didn't understand. So see the answer there. Pretty much same thing. Right. Now, all right, example in instantaneous. So you can have an expression, a displacement expression. So this is what? Displacement versus time. So you get a displacement expression, and you know that this is a curve, right? Some curve there, and you differentiate it. In this case, it is 6.6t square minus t cube. You get 12t minus 3t square. And the acceleration is you differentiate the velocity and you get the acceleration. So in this case, you get 12 minus 6t. All right, so what is x, v, and a at t equals 2 seconds? All right, so right there, you want the displacement at t equals 2 seconds. So the first thing you do, look at the graph, you see at t equals 2, you see what the displacement is 16. Even without transit of the graph, you can pick it up. All right. You also want the velocity, the second graph, when t equals 2. When t equals 2, you drop in 2 in that expression. So each one of them, you just put the time in the expression and you pick up the value. So the first one, when x, the displacement is 6t square minus t cube. 2 into, let me show you, 2 into, you just do the substitution. So it is 6 to t square, sorry, minus 2 cube. So here you will get 24 minus 8. Am I correct? 2 2 is 4, 4 2 is 8. All right. So here, so you'll get what? 16. So see it over here. See it right here. 16 line up with 2. When time is 2. What about the velocity? So the velocity is substituted, put in 2 also. Minus 3 2t square. What do I want to give you? 24 minus 12 is 12 is the answer. So see there at P. Right at the top of the parabolic is 12. What is the acceleration? When you have an expression for velocity, so you can move to the acceleration. Acceleration is this. So you put in 2 in it, you get 2 minus 6 and 2. So you get what? 0. So when the time is 2, the acceleration is 0, not acceleration at that point. Right? Any question? Any question? Are you all with me still? Any question?
Sir, no questions.
No, sir.
Okay, so we're good to go there. All right. All right, so see it work out there. See it all work out. Put them there. Didn't it move a while ago? Okay, so these answers came out. So note that the maximum velocity occur where the acceleration is 0. When the acceleration is 0, maximum velocity is 0. And what is also there? Displacement. And that the slope of the velocity curve is 0. So the slope of the velocity curve is 0 at this point in t equals 7. All right. And then you have some other value there. So maximum displacement is really 32. You can see that as in, if you look at the graph. All right, and you can see what is the velocity at maximum displacement and so forth. And the acceleration also. All right. So it's really showing a relationships. All right, so what time is it now? Can somebody give me the time? What time do we have? Not gonna start anything new. What I'm gonna tell you to do is start the worksheet. The worksheet is there. Start the worksheet. You will give like a week. Standard is a week to do the assignment. So you get a week to start them. You have 2 lovely questions. And I expect you to start it. Tomorrow we'll continue and depends on what's happening. We probably start something different. I think the next topic is simpler math, right? And I need to look at it because I have some videos there. You have some there to watch. We can watch together and have a discussion. Right? So we make the physics exciting. All right. All right. So I'm gonna end it here for tonight. All right. I'm not gonna do anything more. Tomorrow we look at product, vector product, product of vector. Probably I should have it the other way. Vector products. All right. Because that probably need to just fix that one.
So sir, the worksheets are graded assignments?
Yeah, man. Yes, yes.
Oh.
Yeah, man. One before, that's why you do every other question and not grading everything. All right.
Okay.
Vector product. So this is how you deal with 2 vectors. You have vector product and you have scalar product and you have dot product. So you need to know both of them. So we look at that. Not necessarily in detail, but we mention it. All right. And we'll go through these problems. All right, as best as possible. And then we wrap up. So tomorrow we can wrap up this section. And next week we start a new topic. Because I am not dwelling on the topic. So in fact, tomorrow probably what we do, finish up this section and just look at some past papers. And Monday bright and early we start simple math. See, notice I'm not waiting around. We are moving quickly through the syllabus. All right. So okay, tomorrow please. All right, class. Everybody everybody register already? Bacchus, is your name there? Bacchus, drop your name in the chat, sir. Let us get going. Because I'm gonna end the class now. So drop your name in the chat. I'll wrap up this tomorrow and pull some past papers and let us start look at some questions. So tomorrow is going to be a little workout. Get sharpen up on your calculus, so we're gonna get working. All right. Have a blessed one. 9:30 actually go. All right. All right. So have a good.